Alright, so the Waggy's gotten a transmission swap, and the swap I did, or in the middle of doing, is from the Turbo 400 to a GM 6L90E transmission. That's going from a 3-speed to a 6-speed. It's going to give me a lot more low-end power and a lot more drivability on the top end. The Turbo 400 was great, but I think it felt a little more off-roady, if that's a word. It was more like a rock bouncer feel or an off-road rig feel, and whereas I do have an off-road rig, the ultimate goal is not to be a rock bouncer, rock crawler, and just be a purpose-built rig to go beat on the trails. I want to be able to drive across the country, and I can't do that with the Turbo 400. My speed, I was limited to about 65 mile an hour tops, and that is screaming down the highway. You can't have a conversation with the guy next to you. You're constantly hunting for different noises, and so it wasn't a comfortable ride on the highway. And now a lot of you are probably thinking, well, it's an off-road rig. What do you expect? Yeah, it is. You're 100% right. But I can make it better. So that's what I'm going to do. So a few things I'm going to show you on how I'm going to mate up the 6L90 to the Mercedes OM 606. I'm going to show you here. First, I want to say thank you to Dave at NTD Racing. He actually traded me my Turbo 400 for 3 cores of the 6L90 with a low car shifter. So I'll have the tap up, tap down, and all the fancy stuff I can do with it. This is a learning curve for me. This may not be the way you would do it. This is the way I'm going to do it, because this way I know how to do it. It makes sense for me. So what I did is I actually went out and I bought I think PCS makes it, but PCS doesn't sell it. I bought from Zero Gravity Performance the 2650 TCM. So the 6L90 platform has a TCM built in to the transmission and the valve body, so you're not allowed to run a standalone TCM. That was my ultimate goal, is I wanted just a standalone system that I can tune myself, don't have to worry about anything else with it, none of the CAN bus stuff, none of the fancy stuff that goes along with it, because ultimately I want reliability. I want the most simplicity that I can get out of the transmission with this gear ratio. So what I did is I found a TCM that the only 2 sensors it needs is RPM and throttle position sensor. Now, I contacted Zero Gravity before I even ordered this kit. It was like, hey, what kind of signal does the TCM need for RPM? Is this a VR signal? Is this Hall effect? What do I need to make this TCM work? And can I grab this off the tach, or can I grab this off of the alternator on the W terminal that typically guys are grabbing from to run the tach? The answer was the alternator is a little too much of a radical signal. It's not a pure signal, I guess you could say. So the best way is to grab that off of the crank sensor from the OM 606. Now, the OM 606 had a ECM that did not allow for a lot of not necessarily a lot. Kind of lost my train of thought there, but it had a bunch of sensors in it, and everything went to the ECM, and the ECM distributes the information from there wherever it needs to go. I no longer have an ECM. I have a 7.7 millimeter pump from Diesel Pump UK off of the 603 engine, which means that my motor is 100% mechanical. I have 0 sensors. So I had to wire up glow plugs. I used I think a lawnmower starter solenoid, because it has the same amperage I need for it. I can run just a small signal wire to it, And so that's how I control my glow plugs, and it's just a manual button. I can push it, turn them on, and turn them back off. They don't need to run. It's strictly just to get it started. And then that's the only sensor I've used off the motor. Everything else I have wired up, like alternator, everything I've wired up myself as my own harness, my own everything. Relocated the battery to the back. What else? I think that's about it. So now I'm adding a few sensors, and ultimately I did not want to do this, but it is so difficult to find the correct transmission with the right gear ratios that you want, and to give you the drivability and still have a lot of off-road capabilities. So this is what I'm doing. The throttle position sensor that I have is from, I forget who it's from. Looks like it is from E-Trans Control. So this little module here, all it does is you bolt this to your flywheel, or not your flywheel. I'm on crank sensor still because I've been working on the crank sensor all night. You bolt this to your floorboard. This lever, when you push on your throttle pedal down, it pushes this back. So this sensor requires 5 volts, and it's a potentiometer in there that ranges from probably 0 volts to up to 5 volts, and whenever you push your pedal down, it moves this and increases the voltage, sending a throttle position reading out. So all they did is sorry, it's finding a screwdriver real fast. They took a GM throttle position sensor for a GM truck, the most basic one that you can find. Again, simplicity. This is what I liked about it. This keeps me from having to put one on the cable and weld another spot on there and figure all that out. This is just easy. That's all the sensor is. That's your throttle position sensor there. This, on the inside, controls it. So this is allowing me to mount it on the firewall on the inside, and the throttle pedal just touches this bar here and pushes it. So stupid simple, man. What I don't like about it is they 3D printed this out of ABS. Now, in a lot of applications, this might be completely fine. For mine, ABS will not work. I say that because my firewall gets hot, and I do not want to run the risk of it melting. Not that it would, but I just don't want to risk it. So I'm actually probably going to find a machine shop that can mill me out some pieces of billet, and probably going to use similar dimensions and see what I can come up with. I may keep these parts for later use in a different project, or I may keep them if I end up needing them in the future for this Jeep, then I have it. They make a really great product. I just need to refine it a little bit and tailor it to my project. So that's how I'm getting throttle position. Now let's talk crank sensor. So the crank sensor on the OM606 is a VR sensor, variable reluctance. So it has a sensor that goes in through the back of the block, and then it reads the holes. I say holes. I can't remember if it reads the air gaps on the flywheel, like when you have holes inside the flywheel, it reads like those gaps, or if it reads hash marks. I still got to take my flywheel, my adapters and everything back apart to even get the crank sensor out, because it decided it wanted to stay inside the block. And I'm going to check that while I'm there, just so that I know exactly what it's reading, because I have to have that for the input on the TCM to calibrate it. So it has a variable reluctance. The TCM requires a square pulse width modulation. So how do I convert the crank sensor signal from variable reluctance to square pulse width. Well, luckily every crank sensor has two wires, a ground and an out. So let's get down to the nitty-gritty here and talk conversions. This little guy has all of those inputs and outputs. You can see how small he is. This is a Phillips screwdriver. I mean, you can see just how small it actually is. So this converts the signal from variable reluctance to square pulse width. So to make this work right, you see 5 individual leads here. I'm going to wire this up so it'll send signal, but you see 5 volts. How do I get 5 volts now to send to this? Because obviously I can't just put 12 volts to the crank sensor and have a signal come out. I have to transcribe that somehow. So could I have made this? I probably could, but I didn't. I don't want to go through the research of figuring out how to convert all this stuff and all the maths and the nonsense that goes into it. And somebody's already done it for me. I think I paid $90 for 2 of these. The reason being is I got 2 because just in case I accidentally send 12 volts to one and it fries it, I have a backup and future parts. So now the 5 volt question. I got these little doodads off of Amazon. They just break apart into these. So you can see how small this guy is too. Here's the screwdriver. This guy has, let's see if I can get that in the light where you can read it, all different voltages. So you probably can't read it, but we have an adjustment potentiometer here, and then it ranges the top at 12 volts all the way down to 1.8 volts. So I'm taking that. You have to cut the little solder joint on the back side. So that's what I did for the adjustment, or else your output voltage, I think they add together whatever you adjust up to 12 volts. These handle a max current of 3 amps, which is plenty for what I'm going to do. I mean, these things are very handy. You can use these in phone chargers, all sorts of stuff. So for $10 on Amazon, I got 10 of them. And if I end up frying one, I've got 9 more. So what you do, all it is a voltage regulator. So I can apply 12 volts right here on this connection, and then I can apply 12 volts to the second one up here, hold my hand steady, here, and then ground here, and then on the third one up, which is this guy right here, it is voltage out here. I believe that is the ground, if I'm not mistaken. Nope, that is the positive. So then the ground, and I have these wires backwards. This was just a test piece to see exactly what my voltage is going to be and what it all looks like in the end, and it was just wire I had laying around. Wasn't focused on wire color. So this guy's ground, this guy's voltage out, positive hot, negative hot, and 12 volts. So now I have 5 volts coming out of these wires here. I then hook those into the 5 volt and the ground there, right? I then have an out and I have in. So the end portion, I believe, is the crank sensor. Yes. The N positive negative is crank sensor, right? So that's the signal that is received from the crank for RPM. The ground and out, those go to the CAN bus system on the TCM for the tachometer and tachometer ground. And that is my RPM signal. That should, in theory, operate this TCM with every parameter it needs to operate functionally or soundly without messing up. So I'm going to wire those. Real fast, I want to show you guys the TCM that I'm working with because it's pretty cool, and the stuff you can do with it. I didn't realize there was so much stuff you can do with the transmission, but let's just say there might be some push button shifting going on, and I may or may not end up with paddle shifts at some point. Not that I need them, but just because I can, because they're fun to tinker with, I might do that. But let me show you guys real fast. So there is the TCM. That's how it bolts on top of my power supply. There is a broken core, and I'm using it just strictly for test purposes. No, it does not smell on the house. It's brand new. Does not look new, but the case is the only thing messed up. So I've got it plugged in. There's a TCM inside there. This TCM works along with it. And these are all my optional connections. These two, orange and black, the black and white, those are my tachometer. Those obviously are power. Those are for paddle shift right there. I've got USB cable in so I can tune it. That's throttle position, those two wires are. That's about it. So I will eventually go over a video where I'm actually tuning it. What I don't want to do, let me get you set up here. What I don't want to do is bring you along the process of me still learning. I want to be able to give you an informational video where you're learning something that I can teach you. Just because I don't know what I'm doing either. This is just, I'm doing what makes sense, and if something doesn't work, I don't want to tell you the wrong way of doing something. So that's about all I've got. Thank you guys for watching, and hope this helps.